continue. Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar wa sallallahu ala sayidina Muhammad wa ala alihi washabihi wasallam. Walhamdulillahirabbil alamin. Okay. Very good morning to all of you. Welcome to our chemistry workshop. Okay, for subject TST0914 General Chemistry. Okay, semester 1, session 2021-2022. To all medic and also science physical students. So today we doing this workshop, okay, especially for you, in order for you to prepare yourself, to get ready for the final exam. So this workshop actually cover the format and tips, okay, for you to answer this final exam. Okay, so this workshop will be handled by our science coordinator, okay, which is Puan Siti Rubaini, or we can call her as Madam Ruby. So today we are going to do like a santai workshop, a very chill. Okay, kita kita just chill lah, santai-santai. And also we provide you Q&A. I believe that there's a Q&A part, right? Q&A column there. You can write any question and then I will try to answer, okay, during the Q&A, in the Q&A also, ataupun saya akan bagi tahu Madam Ruby lah, okay, soalan mana yang Madam Ruby boleh jawab during the live session ni. Okay, so without further ado, okay, I give this, okay, I handle this workshop to our beloved Madam Ruby, okay, to present the workshop lah. Okay, silakan Madam Ruby. Madam Ruby cuba sharekan konten Madam Ruby. Ada tak?
Okay. Are you sure you want to share? Something is being shared in the live event right now. Anything you share will be replaced. Okay, I share.
Okay.
So now I share. You saw my screen, isn't it? Or not?
Yeah.
Oh, include computer sound tak ya? Are they listening to me?
Yeah, wait. Okay. I already, okay, this one I can see your face only lah, Madam Ruby. Okay.
Dah, jumpa.
Dah, cuba tekan next, backward, next.
Betul.
Okay, good.
Now, I just want to make sure that this is recorded. We have only like 100 attendees, and altogether we are 571 students. I don't know where the rest of the 600 are. Still
hopefully you guys can remind your friend. Please remind your friends to join our workshop. Okay.
Is this recorded? Can you
yes,
make sure
auto,
of it?
Inshallah auto recorded.
Okay.
Because
right, so,
I cannot see the record button here.
Right.
I believe that saya rasa dia memang auto record. Later on, this video dia akan masuk dalam kita punya file yang dalam OneDrive tu, if I'm not mistaken lah.
So you've done this before?
Yes. For the organic workshop tu.
Last time. Okay, so that is good. So I hope we can get the recording for this session and we can distribute to our friends who are still in bed or who are doing the wedding for their siblings or something. Right. Assalamualaikum warahmatullahi wabarakatuh, my dear students. That is my tagline in the video, the YouTube videos that we made. Bismillahirrahmanirrahim. Alhamdulillah, I am able to talk to you spontaneously, not recorded like the one that you have always seen me during the rest of the semester. I believe not only my students, all 571 students are referring to the videos that we made and prepared for you. That is good. We prepare all the materials ready for you for all the lessons in YouTube and also for all the lessons in the Telegram channel. So all you need to do is just um, gather the courage, gather the strength, remove the laziness, and focus onwards to the um, subject, to the course that we're doing, general chemistry. It's easy if you have a good background, but it's not easy if you don't remember anything from school, or you don't remember anything from chapter 1 and so on. So it's quite difficult for people nowadays to um, engage things because they are not really focusing much into the studies. So um, I took the opportunity to talk to you today because I feel that for the last 3 weeks we've been doing Telegram sessions. It is not satisfying for me not to be able to talk to you. Yes, you know, so end of the semester. This is our second last week. Monday would be our last week, week 18. So usually the second last Saturday of the semester, we are going to do a chemistry workshop. So we are going to tell you what are the formats, how to easily tackle the questions, and do a little bit of final exam questions from past years. So this is the outline. I cannot move the slide. What is happening? Give control to me.
No, you control it.
I am controlling it, but I
Yes.
couldn't move the slide.
Try to right click.
Right click. Right click. Okay, next.
Next.
Oh, okay. Okay, now I can. So this is the outline of the. I need to pasang my battery computer first. All right. Okay. Now it's on. The outline of the talk that I'm going to give you is final exam format would be the first one, and then just a simple touch on how to answer, or tips on answering multiple choice questions, tips on answering structured questions, and the biggest part of all, meaning the one that we want you to look and focus at, is the example of how to answer past year questions. I've selected all past year questions beginning from the year 2012. So only 8 questions, but I believe this question will represent the true colors of our final exam. Okay, you have done 70% of the assessment for this semester. So we should be able to breathe or be relaxed, or because you already have 70% most of your grades now. 30% would be just a bit from the 70. Okay. Now, as you have known, we have paper 1 and also we have paper 2. Paper 1, I'm sure you have done it before, previously in all of our tests, in all of our quizzes online via goals. Recently, we have to do it in the middle of the night on Monday because of a goals problem. Eventually, all 5,000 current USIM students are using both at the same time. Previously, it's only us, 800 Tamhidi students. So now all the degree students have come in and they are doing the same thing as us. So that makes the system jammed and we have a lot of difficulty. So those are the kind of things that we have to deal with when it comes to the online and internet connection, coverage, and the capacity of the server and so on. So paper 2 is something new for you since this is something that you're going to do first time for officially in final exam. We have introduced this for only one semester now. Previously, there is no structured question if we are doing online assessment. But this semester is the second time that we're doing this. We introduced this because we think that MC questions is not enough to look at your understanding. So what we're doing is we will be giving you two sets of structured questions and then you're going to answer them according to the marks that is given. And your batch is also the first time that we are giving a very specific questions representing only for chapter 6 and chapter 7 only. You see, previously for the batches before you, your seniors, your elder brothers and sisters, we ask everything, the whole general chemistry course from chapter 1 to chapter 7 for 5 Chancellor Hall. But since we are doing it online and we have so little time, I think you can see the messages there and it is distracting as well. So we are going to specify the questions only for these two chapters only. But bear in mind that um, we are going to use also the components from chapter 1, for example, calculating the number of mole, from chapter 2, calculating the partial pressure, and so on. So I believe that we have to integrate all the chapters that we have learned from chapter 1 to chapter 5 in order to answer questions in chapter 6 and chapter 7, as I have always said to my students. Okay? If you find that I talk so fast, maybe you can look at the recordings later. This is how I am in the class. Sorry, the words that I'm saying myself in Malay, since this is a formal workshop recorded. If it is a regular class, then I can use a bit of Malay, Arabic, a little bit. But this is full English, and your friend, Madam Junaidah Madin, is going to assess me on this because she is my all-time English teacher. Right. So the first paper that we're going to look at is paper 1, which is of only 20 questions. Last year we gave 30. This year we give only 20, and you will be answering this within 45 minutes because we want you to focus on the question and do not think of the structured question. Some course they do the structured question and the multiple choice question all at the same time for 2 hours. That will make you hesitate a little bit. What do I want to do first, MCQ ke is that finish MCQ 20 questions altogether within 5 minutes only, and then you submit, and then that's it. You can go and have your rest for about 45 minutes after that, before you go for paper 2. Usually the internet connection at my house is a bit slow on Saturday morning. So I hope if it is lagged, then that would be internet problem lah. Okay. Bloom taxonomy have 6 levels, and for pre-university students, we will measure you your abilities using 3 levels only, C1, C2, and C3. So within the multiple choice question, we have the level that is easy, the level that is not too easy, meaning that it is to show your understanding. Level 1 is hafal and luah. Level 2 is to show your level of understanding. Level 3 is to apply your knowledge into the concept. So there are 3 levels that we are going to test you in MCQ questions. Okay. And then we're going to look at final exam format for paper 2. Now paper 2 is having 2 questions. One question is for chapter 6, chemical equilibrium. One question, the second one, would be for chapter 7, ionic equilibria. And each question will be given 15 marks each. Now we're going to give you 1A, 1 Roman, for example, 2 Roman, 1B, and so on. So it is structured. Structured means soalan 1, you have anak A, and then anak A ada anak 1 and 2 and 3 Roman. So
maybe you can draw a bit on the slide.
Draw. Okay. Good answer. Good suggestion. Tunjuk-tunjuk dengan tangannya mana, nampak kan?
Yes.
Thank you. Tak dengar suara saya
Clear?
Clear?
I can hear your voice.
And everybody can see the messages. Do you realize? Okay. For example, we have question 1 and then 1A. Good. And then 1A, 1 Roman. So 1 Roman here gives you 1 mark, for example. 1A2 give you 2 marks, for example. And then 1B. So this is called structured question. Structured question. We don't give you essay question. Essay question, like the one that is answered by your seniors. Essay question, question number 1. Okay, we have an essay. Essay here, and then gedebak 25 marks. This one is essay question. It's not that you have to answer using essay. We give you question using essay. But then this is not related to you. I just want to compare it against our structured question. So we have 1 question for chapter 6, and then question number 2 would be for chapter 7. Okay, also we have 3 levels of difficulty. So this one would be C1, for example. This one would be C2, for example. And then you have to answer within 75 minutes. 75 minutes meaning 1 hour, 1 hour and a quarter. So this is the interface of our goals. We are going to have a different page, not the same page as we did our tests in the system, because you have all the notes there. You have the link and all. So we're going to use a different site, same as we did for the mid-semester exam. For your batch, it's the same. For it's the first time for mid-semester exam. Okay. Now, this is some a bit of a thing that we think might help you on how to answer MCQ questions. MCQ question will test you and your understanding throughout the whole thing, meaning that you have to know everything in order to answer the question. So the first step would be for you to read the question, and then you have to answer it in your mind first, meaning that maybe I'm going to use this formula, and then maybe the answer would be this. So you have the draft in your mind, or you want to jot it down in your draft paper. And then you have to eliminate the things that you think at first would not be the answer. Either use the true or false elimination, or you can look the answers hidden in the question. Ada maksud tersirat in one or two of the pilihan jawapan. And then you select the best answer, and then you answer the question that you know first. And then you leave the questions that you think you need time to answer. So this is why we separate between paper 1 and paper 2. We want you to get done with paper 1 just as that. Because if we combine the MCQ part and the structure part, you would be in a rush, because maybe MCQ question you haven't answered 2 question, you already go to paper 2 or the structured part. So we want you to get done with MCQ and then submit. That's it. The answer is there. So I'm not going to talk much about this. I know you have your experience. That is your observation lah. Maybe you can find the longest would usually be the answer, or the shortest would be the longest would be the answer. That's your own observation. Okay. Like I said, this is only the tips of an iceberg. The tips on answering the questions. So the structured question, again, we have question number 2, for example. This is first part and this is the second part. And then we have also maybe anak dia, 1 Roman, and another anak, 2 Roman, and B. And then maybe C, B tak ada anak, maybe C ada 1 anak, ada 2 anak, 3, maybe ada 4. I don't know what will you get, but the whole thing would give you 15 marks. The whole thing would give you 15 marks. So we call it structured question because it's easy for you to look at the marks. For this one, it is only 1 mark. For this one, it has to be 2 marks. So you know what you have to give. The same as when we are doing tutorial, we give you marks. Why do we give you marks? Because we want you to know where the points are, so that you can look at the marks given, and then you can check the points that you give, whether they are completed or not. So the first thing that you have to do is read the question. And then I know a lot of you will list the information given. For example, pressure is how much, temperature is how much, and then you calculate and convert it into Kelvin. So this is normal. You know what to do already. And then the formula, you have to list the formula. So the formula that we're going to use, maybe Kp equals to Kc RT delta N. This is also another mistake that students use. Why? Because firstly, lack of exercise. So they will do RT delta N. Delta N ni untuk siapa? Untuk T sahaja. So this is wrong, right? When you lack of exercise, you don't do the tutorial questions thoroughly, or the tutorial questions at the back of the book, that would lead to you to the mistake. So this is the common mistake that students do. They forgot that this is actually a bracket, a big bracket where delta N would be for RT, not only for T. So this is about the formula. The formula that you're going to memorize for chapter 6 and 7 among all is also Henderson-Hasselbalch equation for both acidic and basic buffer solution. Yes, so you have to look at that. Okay. As you have looked at the marks given, you can draft your answers step by step in your draft paper or even in the question paper itself, or the one that you have in front of you. And then you should write the answers in clear handwriting. Some of you like to use pencil. If you use pencil, it is quite hard for us to look at the clarity of the font. So I suggest that you use pen, please. You use pen, and if you have any mistake, you can just cut it off and write it again.
One more thing, Madam Ruby, blank A4 paper, not foolscap paper.
Yes, please. Can we use blank A4 page? Thank you, Sir Afif. Because when we want to look at your handwriting, sometimes the line will distract us. If you could use A4 blank page, it would be easier for us to mark, and your pen would be showing beautifully written clear answers. That is a good point there. Okay. Apart from writing your answers clearly, if we have a calculation, we suggest that you recalculate the values for your answer. Meaning semak jawapan. If the second time you press the calculator, it is wrong from the first time, you need to do it the third time. Sometimes using the calculator gives you a mistake. We have done this a couple of times in tutorial session. Tersilap tekan calculator. Okay, so it is good that sometimes you calculate using a different way. Using algebra. Mula-mula yang ini jadi sebelah kanan, lepas tu yang ni jadi sebelah kiri. Just venture so that you know that your answer is correct. Kalau dapat jawapan yang berbeza, 2 kali tekan, then that would be dipertikaikan lah jawapan tu. Okay. So finally, when you have written all your answers, you have to check whether the points that you give is correct or not. If, for example, soalan C 1 ni dia bagi 4 markah, we allocated 4 marks there, but then your answer would be no change. Tu je jawapan dia. So is it logical with this answer will give you 4 marks? No, right? So maybe you need to add a little bit of explanation. If it is 4 marks, bukan explanation ni, explanation 2 marks, calculation 2 marks, for example. So this is an example of the question. Okay, so I think that's it for the tips or how to answer the question. Tak banyak pun. Habis juga setengah jam kan, Sir Afif? Ingatkan sikit je nak bercakap, rupanya setengah jam. Okay, kalau saya kalau saya terlebih ataupun tercakap benda-benda yang tak berkaitan, you need to tell me, Sir Afif.
Okay.
Okay. Right. Now, we are moving forward to the example of final exam from past year. Okay. This is the most recent, semester 1, 2019, 2020. This is the last exam that we did face to face in Dewan Tuanku Chancellor. Lepas tu, lepas daripada semester ni, terus semua exam online sebab pandemik. Kan? This is around bila Mei kan? Mei 2000
semester 1 of course end of the year.
End of the year Oktober ke? Oktober 2020. October 2019. Yes.
Around October or November I think.
October 2019. This is the last semester we do class all or fully face to face. Lepas tu exam pun dekat exam hall. So it's proper lah. Which of the following equation suits the expression of Kc as shown below? So this is from chapter 6, and this is only lesson awal-awal lah. I don't remember the number of the lesson anymore. As you remember, we have a general equation AA plus BB becoming CC plus DD. And I've insisted in my class we have to use the word stoichiometric.
Okay, Madam Ruby line is stuttering. Madam Ruby, hello. Madam Ruby line, a bit problem there.
Kak Ruby hilang. Aku hilang pergi mana?
Okay, Ruby. Okay, there you go.
Am I back?
You're missing in action just now.
This is Saturday line. Saturday line is all about, people gathering, family gatherings online and so on.
Okay, continue, Madam Ruby.
Okay.
Okay, fine, okay.
Right. The A, B, C, D is called stoichiometric coefficients. All 571 students of Tamhidi Science in 2021-2022, you must use this term. You don't use mole. You don't use mole because mole is N. Okay? Alright. So I am glad that for my some of my class ada yang berjaya mengeluarkan perkataan ini dalam kelas bila saya tanya secara live. Alhamdulillah. I'm so happy about that. Because sometimes even though we are science students, when I ask things like this, you feel this term is foreign. This is actually the term that must be near to your heart. When we do chemical equation, we have stoichiometric coefficient at the beginning of every equation that we are learning. Okay, so how to make the Kc for this general equation? Okay, as we know, the concentration of C to the power of C multiply the concentration of D to the power of D. The product would be at the upper part of the formula and the reactant would be at the lower part of the formula. Okay, so this is the basic thing that you have to know in order to answer this question. So I'm sure that you know you have to help yourself, you have to focus, you have to study, then you will be able to answer this question. There's no way that you can ask your friend or look at the book or look at the video at that time because the time is so short for you. That's why we don't give 2 hours for 20 questions. You would know what to do. Okay. So for this formula, it is given Kc. So H2S and I2 must be the product, right? And this must be the reactant. The product would be on the right. This is the right side. So where is H2S? We have here. Okay, there are two options there. So we can already eliminate A and we can already eliminate D. Okay. So now the matter, it comes to the matter to choose whether it is B or C. So for this KC, the stoichiometric coefficient is it doesn't show this is number 1, this is number 1. It doesn't show there, but we know it's there, right? So the stoichiometric coefficient would be 1 here. It doesn't show also, and 1 here. It is not half. This is not the answer because it's not half over here, kan? So the answer would be B. Okay? Apa pasal yang warna merah ni tak hilang? Okay. The answer would be there in the red box. Alright. Next, question number 2. This is the final exam paper for the year 15-16. Saya ambil set A je, set B saya tak tengok pun. Tu kita punya backup. So nitrogen dioxide decomposes on heat according to the equation. The equation is given to you. Okay, this is the equation 2NO2 becoming 2NO plus O2, where this is homogeneous equilibrium. And we are given when 5 mole of nitrogen dioxide was placed in a container of 2 dm cube. 2 dm cube is 2 liter, kan? And was heated to a certain constant temperature, the equilibrium mixture then contained 0.9 mole of oxygen. 0.9 mole of oxygen. Okay, so what is the numerical value for the equilibrium constant Kc at the temperature of the experiment? Numerical value means dia dah bagi formula macam ni, then it's easy for us to choose. We don't have to actually press the calculator that much, and so we avoid the mistake of pressing the calculator. So what do we have to do? I think I want you to understand that if the question state that when 5 mole of nitrogen dioxide was placed in a container, it gives us the clue that this is the initial state ataupun initial condition, meaning that we are going to use the ice table. We have to use the ice table. So 2NO2 okay, is going to transform into 2NO plus O2, whereby the initial mole. So we want to find the initial concentration, right? So initial concentration would be 5 mole. What is the volume? Concentration N sama dengan mv. So M sama dengan N over V. This is my only formula. The one that we learn in chapter 1, the one that you learned previously in school, and the one that you're going to use forever. Because yesterday, I had a meeting with a lecturer in FST. She said, Kak Ruby, student saya tak tahu nak dilute solution. Second year, baru first time masuk lab after PKP, tak tahu nak buat dilution. Kat mana dia orang belajar buat dilution bila? So I tell her, during matric, during tamhidi, they should do dilution. M1 V1 equals to M2 V2. And then this is related to the number of mole. This is basic for us people of science. When we are doing our PhD even, we have to sit down in the lab and then you have to make the calculation in order to get that particular solution that you need for your experiment. Okay. So jauhnya Madam Ruby pergi bercakap kan. What is the volume? Nak tanya satu je. What is the volume of the container of the flask? Where is it? Where is it? Here. It's this one, right? So yes, you can use the M cube. As I said just now, the M cube is also the same as liter. So kita tulislah sini mole per dm cube. So the answer, the concentration would be 2.5. Kan? Molar. Okay. And at the beginning, we don't have anything for the product. And what is the change? This is the ice table. Ice for initial, C for change, and E for equilibrium. Just a revision for you in case you are not familiar yet with ice table. Tak buat lagi practice. Saya minta buat practice bagi jawapan senyap. Klik, 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 klik. Bilalah nak penuh channel. Dia kena ada seorang. Seorang hantar, Madam Ruby tanda and then Madam Ruby letak dekat channel. So, siapa-siapa yang nak bagi soalan praktis tu dipersilakan. Right. The change here, we are going to lose a bit of some part in 2.5. 2.5 molarity is the whole thing. So when it convert the reactant into product, the reactant will change, will reduce its content as much as 2x because we use the stoichiometric coefficient 2 and x is the unknown that we're going to find. Okay, and then for product, okay, we are going to get increase of product as much as 2x and also O2. O2 is x. Alright. So next we're going to look at equilibrium. Okay, what is the information given to us? As it was heated to a certain constant temperature, the equilibrium mixture contains 0.9 mole of oxygen. 0.9 mole bukan kepekatan, tapi masih lagi bilangan mole. So 0.9 mole of oxygen is situated here. This is oxygen. So 0.9 mole. At equilibrium, the concentration of oxygen gas is measured to be having 0.9 moles of oxygen gas. So we need to find the concentration. Therefore, yang ini agak tak ada dalam examples. Sebab biasanya example kita bagi concentration terus untuk equilibrium. Kali ni still kena bahagi dengan container punya volume because the oxygen would be enclosed in the system. Dia tak keluar lah kan. So the answer for X would be berapa ni? 0.45. Is that right? Do I need to press the calculator? Alright. So X is 0.45. Here, for NO, okay, the equilibrium concentration is 2x. Now we know that X is 0.45. Therefore, the concentration for nitrogen oxide gas would be 0.9 molar. Okay. If this is structured question, This would give you 1 mark, this would give you 1 mark, and the whole table would give you 1 mark. And then the concentration of nitrogen dioxide is negative 2x, 2.5 minus 2x, where x is 0.45. So the concentration would be 2.5 minus 0.9 is 1.6. 1.6. Where's my cursor? 1.6 molar. So this is another mark if it is a structured question. Since it is an MCQ question, there's only 1 mark lah. So we have to do the Kc expression now. Okay, Kc expression. You can see that you are using a lot of time for this second question, more than 2 minutes. So that is why we hope you can do the easy questions first, and then you spend more time on this calculation question. So Kc would be the concentration of NO to the power of 2 multiplied by the concentration of oxygen gas divided by the concentration of NO2 to the power of 2. So you substitute the value. The value for NO is this one, okay, 0.9 to the power of 2, and then O2 is 0.45 to the power of 1, and then NO2 would be 1.6 to the power of 2. So who can give me what is the answer? Where is the answer? Is it A, B, C or D? Oh, they cannot respond, Sir Afif. Mana jawapan dia? A, B, C or D? So the answer would be, sengaja dia letak 4.5 ni sebelah kiri. Kan? So the answer would be B. Because this is 0.9 to the power of 2, 0.45, 1.6 to the power of 2. So we have done question number 2 now. Okay? All right. Okay, do we want to take a break, Sir Afif?
Now 10, almost 10:20 lah. Okay, so maybe we can take a break about 5 or 10 minutes.
10 minutes lah.
We continue.
Buat macam kelas biasa. 2 jam break.
So we continue at 10:30. Okay?
So any questions you can ask, type in the
Q&A session. Okay. For now, we are going to mute and mute our voice lah. Okay.
Okay, it's 10:30. Can everybody hear me? Safif, are you there? Latifa, are you there? Can you hear me? 274 attendees. What kind of percentage is that? 274, 571. Tak sampai half. 48% only attendees. Okay, can somebody just tell me in the Telegram perhaps if you can hear me clearly so that I can proceed? Okay, Alhamdulillah. Thank you, Haikal. All right. So, resume slideshow. This is not a slideshow. I want to do the... Okay, thank you. Oh, banyak pula. Alhamdulillah. Okay, very good. Thank you. Thank you very much. So, you can see the slide, right? Okay, so I will carry this on. I think something is going on Safif and Madam Tifa's side, no problem. Dr. Jana is also watching. Okay, so let's look at the third question. I chose only 8 questions, so we're going to do the rest of the questions until 11:30, I hope, and we will finish on time. Right. As we have done KC, now we are going to do KP. Where does this question comes from? I didn't put it. From which year? Okay. So the question said, the equilibrium is achieved when 0.5 of PCl5 has dissociated at T degrees Celsius. This is the temperature where the reaction is going. 0.5 is the degree of dissociation, whereby at the beginning, let me do this here. At the beginning, PCl5, yes, you have to write down the state or the phase whenever you write the equation, but sometimes when I'm doing calculation for objective questions, sometimes I left out with this one. So if you are doing the structured question, please put the phase as well. Okay, somebody just asked about this because I forgot to put it here. Where did I forgot? Here, I forgot to put it here. Okay, so this is an MCQ question, so that's why I did not emphasize on that. But if this is a structured question, yes, you can get as much as 1, 2, 3, 4, 5, 6 marks for this question. Okay, for question number 2. All right. For this question, we know that at the beginning of the reaction, we have 1. This is 100%, and then 0 and 0. Okay, and then after the equilibrium is achieved, the percent dissociation or degree of dissociation of the reactant is 0.5. Okay, therefore, the product would be 0.5 and 0.5 as well. So it's the same as this is negative x, this is positive x, and the positive x, but the x is actually given to you. The x is 0.5. But the thing is, logically, we are not even going to use this information. I don't really have to give you the 0.5 in the question, because the next information is the most important part, where it says if the total pressure at equilibrium is P, the total pressure, the pressure total is actually P. So what is P? P is the pressure of PCl5 and then plus partial pressure of PCl3 plus the partial pressure of Cl2. Okay, so this is actually the P. All these three combined together becomes P. Meaning that this is 1/3, this is 1/3, this is 1/3. Mix this together, so you get P. So you got P. Because for me, this question is testing the whole thing. If you understand, you are able to use your logic thinking to answer the question. Because it's quite tricky to explain when it comes to using the ice table, basic formula, and so on. So what I'm saying is, if we want to find PCl2 for example, this is actually P/3. Nampak tak? Okay, I'm not even using the ice table. But if we use ice table, we will get 0.5 over 1.5. This is actually 1/3 jugalah kan? 1/3 of P. For example, this is PCl5. So PCl5 is 1/3 P. And then if I use the information total pressure, this is total pressure. Total pressure is consisting of the three pressures together, because the stoichiometric coefficient is 1, 1, 1, right? So the partial pressure for each of the gas in this equation is actually P/3. So this is how we understand the question and we try to answer the question as it is. So that reminds me, I forgot to answer KSF1 questions from yesterday. KP, what is the value of KP? So what is the KP expression? KP expression would be P PCl3 to the power of 1, PCl2 to the power of 1 divided by PCl5 to the power of 1. So what do we have to do? We just insert this into the whole thing, P/3, and then P/3, and then you cross out one with 1, and then the answer is P/3. We have the answer? Yes. So basically, when you are dealing with ice table, with KP, with KC, sometimes we don't give you the actual value. We give you an unknown P. So you use the unknown P into the formula, and then you will get the answer dalam sebutan P. So there are several questions like this that will come out in the final exam. The ones that is made by Sir Afif, the one that is made by Madam Latifa. I think 2 or 3 questions like this, but it is randomly given to you. Kalau you dapat 3, that would be your luck lah. Tapi I suspect most of you will get at least one question like this. The question that you are using the ice table, but at the same time, the values given is not the numerical value. The values given is an unknown. So you have to find the formula, the answer in terms of formula yang ada sebutan unknown tersebut. Okay. So this is question number 3. Alhamdulillah. Okay. Now we go to ada lagi soalan chapter 6 kemudian pasal Chatelier principle, tapi dia dah tak ikut susunan dah ni. This is chapter 7 already. Chapter 7 is on acid and base. Okay, you have to know the definition of Arrhenius. Yes, Afif.
Madam Ruby, before we proceed with chapter question 4 ni, back to question 3 ni,
yes.
What clue ada soalan, there's a question from Nisrin here.
Okay.
Madam, what clue on the question that we need to use ice table?
What clue?
What is the clue on the question?
You are finding the tips lah. Okay.
That we need to use the ice table. Means like maybe ada question that we will use ice table. Maybe there's a question that not going to use ice table.
Okay, I understand that.
Be spontaneously lah. Okay.
Spontaneously, I am thinking, should I share the practices in our book? Tu banyak sangat kan? The practices in our book.
Practices Okay. Sambil tu saya pun tengok kejap
Saya nak keluar ni, dah keluar dah. Okay. That is a good question. Now you know everything that I have kan in my laptop. I am actually presenting this, right?
Right now on the screen that I can see that PowerPoint
je.
PowerPoint of
Okay.
question 3 I think.
Alamak, I have to share the screen lah in that case, desktop. Okay. Nampak? Okay, nampak
Okay.
Okay.
I think this one may be difference of problem type 1 or type 2.
Yes, that is what I want to show you. Problem in KC and KP. Yes. It's just that masa saya terangkan soalan nombor 3 tu, saya tunjuk dia punya ice table sebab saya nak bagi faham apa yang berlaku sebelum dan selepas dan apa kaitan dia dengan degree of dissociation. Okay, so ini that this is the part where we are doing KC and KP problem and calculation. So there are two types. The types are when we are given equilibrium quantities. This is the equilibrium quantities where, for example, the question would say, in one experiment, the concentration of the reacting species at equilibrium. So if you see the word at equilibrium, you don't have to use the ice table because you can use the values straight into the KC expression. So that this is type 1.
Is already at the equilibrium.
The question state that these concentrations are at equilibrium. So you can just use the KC expression, put the values inside the KC or KP. Okay. And then the type B question, when we are given initial quantities, that is when we have to use ice table. When we are using ice table, the question will give you the initial quantities of the species. For example, at certain temperature, a mixture of H2 and I2 was prepared. by placing 0.2 mole of blah blah, 0.2 mole of blah blah into the 2-liter flask. Okay, so this is the initial quantities. So you have to do the ice table, and then in order to get the X, we need to find the equilibrium concentration. At least one value will be given to you. At equilibrium, the concentration of I2 had dropped to 0.02 molar. Okay, so this is the keywords. Here it says at a certain temperature, a mixture was prepared by. So this means that the reaction has not yet begun. So this is the initial condition. And then after a while, at equilibrium, the concentration of I2 only is given to you. If I2 is given to you, and you can find the X. So you can find the equilibrium for the rest of the species H2 and HI. So you can put the equilibrium concentration into the Kc expression. For example, again here, let's read the practice. This is the practice that I am waiting for my students to give me the answer. The final answer is given to you here, so it's easier for you to tackle the question. So just send in anytime the answer so that I can mark and I can put in the Telegram channel. Now, for question number 1, if the partial pressure of NO2 in a container is 0.15 atm at equilibrium. So this is at equilibrium. So you don't have to use the ice table for this question. Question number 2. If in the reaction vessel at this temperature, there are 0.25 and 0. At equilibrium, again, this is stating it is at equilibrium. So you don't have to use the ice table, you just use the value, put into the Kc expression. This question is giving you the value of Kc, so you need to find the concentration of N2. So, okay, kita tengok yang last. 0.2 mole of hydrogen halide is injected into 2 liter. So is injected means that the reaction has not yet begun. Meaning this is the initial condition where the reaction will start. And then HI concentration is 0.078 at equilibrium. So you can find X and you can find the other concentration at equilibrium. Then you can find Kc. So question number 5 is using ice table. Okay, back to our question 3. I use the ice table to show you the meaning of degree of dissociation. We don't actually have to use ice table here. As I've shown you in the next step here, total pressure. Pt equals to PCl5 plus PCl3 plus PCl2, where we will get the partial pressure for each gas, which is the same, P/3. This is a special question to test you whether you understand the whole thing or not. That is why MCQ question is a bit tricky to tackle. Okay, I thank you for the question that is given by siapa Miss Rin?
Miss Rin.
Okay, thank you.
Okay, thank you very much, Miss Rin. So, Medrubi, please proceed. 10:50 already.
Oh ya, okay. Nak kena kejar masa. Jap. Saya nak pilih soalan lah. Kita siapkan chapter 6 dululah, kan?
Okay.
So
maybe you can
go to Chatelier.
Review the slide.
Okay. Chapter 4 is question 4 is acid base. KSP is also chapter 7. Fine. This is chapter 6. So kita buat chapter 6 dulu. Past year of 2016-2017 at 1000 Kelvin. The initial concentration of carbon monoxide, hydrogen gas, methane gas, and hydrogen gas. Salah type ni, H2O. This is H2O. R 0.0025. Apa ni? Okay, this is H2O. R 0.025, 0.0018, 0.0041, and 0.0082 molar respectively. If the equilibrium constant Kc for the reaction is 40 at this temperature, predict the direction of the reaction. So this is another type of question that is always going to come out to look at the quotient. Quotient, what is quotient? Quotient is the state of equilibrium at a particular point, whereby it is not actually the state of equilibrium, it is the state of condition. It is still going on to achieve equilibrium. For example, you put two gas, you put CO and 3H2 into a container, and then it will become CH4 and H2O. Okay, at certain point, maybe after 5 minutes, you measure the concentration of all four gases. And then you want to know whether this reaction has already achieved equilibrium and going back to its original state, or it is going towards equilibrium, going to the right. So we are going to use the Kc expression here, where CH4 to the power of 1 multiplied by H2O to the power of 1 divided by CO to the power of 1 and H2 to the power of 3. So we are going to insert the values given in the question. CH4 is 0.0041, H2O is 0.0082, and then CO is 0.0025, followed by H2 is 0.00818. Memang hari ini memang hari Sabtu pagi memang terkenal dengan masalah lain, Nana Pipa. So saya dekat rumah saya pun sama. Sabtu pagi ni lah mungkin dia nak buat maintenance, bukan dekat USIM saja, dekat mana-mana tempat. So I am pressing my calculator right now. Itu divide by, ni kuasa 3 ni terlupa. H2 kuasa 3 Okay, divide by 0.0025 divide by 0.0018, 0.0018. Saya cara lama tekan banyak kali. So the answer would be, wow, besarnya 2.3 1 240-an cukup lah, kali 10 kuasa 1, 2, 3, 4, 5, 6 10 to the power of 6. What is the unit? How do we find the unit? This is molar, this is molar, this is molar, this is molar kuasa 3. So potong 1, ni tinggal 2. So the unit is M-2. So this is the answer for QC. Kc is given to you 40. So 40 is actually less than 2.31 times 10 to the power of 6. So what is the thing? Sepatutnya saya buat kat sini tadi. Q is bigger than K. The ratio of initial concentration of products to reactant is too large To reach equilibrium, the product must be converted to reactant. The system proceeds from right to left, meaning that this is a table that you are going to refer and you are going to remember, so that if we have QC is bigger than KC, the system is not at equilibrium. The system reaction will proceed from right to left, from right to left, meaning that this reaction has been over here onto the right. So dia nak kena patah balik ke sini supaya dia mencapai keseimbangan. So this is how you predict the direction of the reaction. Where are the marks? Ada 5 markah. Okay, the marks is 1 mark for the QC expression, and then 1 mark for the final QC value, and then you compare. This is the comparison, is 1 mark, and then you will say the system is not at equilibrium. This statement is so free mark. Whenever you are faced with this question, even if you are confused, you might get 2 marks free. Where is the 2 marks free? When you are doing the QC expression and you are stating system is not at equilibrium. We know that the system is not at equilibrium. Otherwise, it won't ask to predict the direction. But this statement will give you 1 mark. So this is why I said it is a free mark. Okay. And then the final statement, reaction will proceed from right to left. This is the final answer. So you are going to get 5/5 marks, a minimum. Sometimes I will give you extra for here, substitution. And sometimes I will give you bonus here, extra for calculating the unit separately. We are calculating the unit separately, isn't it? So that would give you time, occupied time. Therefore, if we want to give bonus mark, we will decide later when we are doing the marking together. Okay, we are doing the marking online together as well, so that everything is going to be centralized and coordinated. Supaya ada yang strict tu kita rendahkan sikit strict dia. Ada yang lenient macam saya asyik bagi markah je, kena strictkan sikit kan. Okay, so next we have done this one. This is the proper answer. Okay, this is Le Chatelier's principles. I want to talk about Le Chatelier's principles, the last part of chapter Le Chatelier's principles. The last part of chapter 6. What does Le Chatelier principle say? Le Chatelier principle said that if a system is interrupted with a change in whatever way, increase of temperature, increase of concentration, increase of pressure or volume, it will try its best to counter back or overcome the change so that it will come back to its equilibrium state. I do not memorize the ayah, bilugha, but I understand the concept, so I am giving you my own words. So I hope you will be able to understand what Le Chatelier's principle is if we ask you the definition. Okay, and also the metaphor is, for example, we are swimming in a very cold pool in Cameron Highland, for example, and our body is telling us, I am cold, I am cold, I want to be warm. So our body is trying to get back to equilibrium of 37 degrees Celsius. Kita pun keluar daripada kolam, berjemur di tengah panas. So that is how our body works to um, to um, to to control or to fight back with the change that is given to our body naturally. So same thing happen for reaction in the test tube. If we are given extreme condition, temperature, pressure and volume is changed, the system will try to overcome the change and it will move to the place where whether it's right or left. Kan? So there are a lot of factors. The first one is concentration, the second one is temperature, the third one is pressure and volume, and then catalyst. These are the four factors. And then if I want to give you a brief simple thing, for example, I am using this question, N2 gas plus 3H2 gas becoming ammonia to in form of gas. Okay, so if we increase the concentration of nitrogen gas, okay, the system will move to the right so that the concentration of the product will also be increased. That is the logic thinking of what we can answer if the question wants to change the concentration of any of the species. If the concentration of product NH3, for example, is given, is increased, therefore the reaction will shift to the left in order to achieve equilibrium, because the concentration of N2 and H2 will also has to increase. Okay. Next, this is about the question, temperature. This is about the question. So the question is asking you to choose the correct statement for the underlying species in the equation below when the temperature of the system is increased. Now the temperature of the system is increased. When the temperature increase for an exothermic reaction, what will happen? Okay, I have a formula of my own whereby I will look at the endothermic reaction. This is endothermic reaction. For endothermic reaction, if the temperature will increase, the product will be produced more, so the reaction will go to the right. This is what I remember because observation of doing lab experiments and so on, because it's logical. When you increase the temperature, of course, the reaction will proceed vastly. Therefore, the product will increase. The product, bukan pressure. Product. Okay, so here we have exothermic. For exothermic reaction, when the temperature increase, the product we want to decrease. So the reaction will move to the left. So underlying species, okay, the underlying species will be the product. Therefore, the product we want to reduce here. The product we want to reduce, and I believe the answer is A. Now let's read the others. It is removed from the system. Now it is removed from the system, but it is going to turn into the reactant. So it's not entirely true if it's removed from the system. And then the concentration is decrease. This is so against the thing that we have discussed here, and the concentration remains the same. This is basically out. Awal-awal lagi dah out sebab dia takkan stay sama. Okay, so I hope you would understand what you have to do for the Chatelier's principles. Okay, next I'm going to talk to you about pressure. So my formula is, when we want to talk about pressure, I'm sure you have read all the things in the Telegram, watched YouTube videos. Sometimes when we give you a lot of examples, it seems a bit berserabut, banyak sangat. So to conclude that, if we have 2A becoming B, okay, and you increase the pressure where the volume will decrease, the reaction will turn to the right. Turn to right. When I talk to you, I write turn to right. But if for me, I will just do this arrow because I want to know it is left to right. So this is my way of remembering things. And then if we have A becoming to B, okay, when the pressure increase and the volume decrease, it will turn to the left. It will move to the left. So look at the stoichiometric coefficient of the equation that is given to you, balance, and you will know what to do if you are given whether the pressure or the volume is, whether it is increasing or decreasing. So this is the some sort of like a simple statement. Catalyst does not involve much because it doesn't change the activation energy, but it will speed up the reaction. It will make the reaction achieve equilibrium more faster than before. So that is the function of catalyst. Okay, we have done question 7 on the Chatelier's principles. Is there any questions, Afif? I didn't read anything.
Okay, no, proceed.
Proceed,
maybe this one, maybe you can answer spontaneously. Can we make our definition based on our understanding?
Yes. Yes, you can.
Yes, but there's still some terms that you cannot tukar
Run away
sesuka
from.
hati lah.
And then make sure that we understand that definition. You cannot run away from the word equilibrium, change, or
balance.
Yes. Because I know the definition in the that's given to you is quite using heavy terms that you don't use usually, kan? So we hope we hope you can understand, and then if you have trouble luahkan balik benda tu, then of course it's preferred to use your own understanding, your own words. You have to show that you understand the definition. Kalau you rasa kurang pasti dengan satu ayat yang you bagi, maybe you can give example, for example. Tapi tu dah panjang lah juga, kan? Sebab this is like this is just C1 question.
Definition is just only level C1.
Hafal dan luah. Tapi saya tak nak galakkan you hafal sebiji-sebiji, nanti you lupa cepat. Sebab kita nak faham konsep, kan? Okay. So you need to show us that you understand what is happening. What is actually explained by the definition. What is the definition all about? Okay. Now we have finished chapter 6 basically, and I'm going to proceed. I'm going to proceed on chapter 7. So as I mentioned just now, earlier, we have 3 types of definition for acid and base. They are Arrhenius, Bronsted-Lowry, and also Lewis. So Lewis is regarding electron lone pairs. So this is connected to chapter 5 as well. So you need to be able to merge your knowledge from chapter 5. Macam mana kita nak letak this is the lone pair for NH3 for example, kan, ammonia. So this is basically base lah, kan. So the first part of chapter 7 is you have to calculate the pH. Before this, you only learn acid will turn the litmus paper from blue to red. That's it. There's no value of the pH that is you have to calculate. Nowadays, the value of pH, okay, is basically negative log H plus. This is the ultimate formula that you have to remember. Of course, it's quite easy to remember. It's just that you have to look at the acid or base you are given, whether it is a strong base or strong acid, or weak base or weak acid. For strong base and strong acid, it will ionize completely. Completely ionize. It will completely ionize, meaning that it will going to use this straight arrow. But if it is weak acid or base, it will be partially ionized, so it would have this sign, this arrow, tindak balas berbalik. So it is critical for you to notice this difference. So sulfuric acid is a strong acid. So strong acid, H2SO4, okay, aqueous, is basically ionized completely. So it will form 2H plus aqueous and SO4 2 minus aqueous. So this is the dissociation equation, balance one for the sulfuric acid. And we know that for 1 mole of sulfuric acid, it will fully dissociate to form 2 mole of H plus ion. Therefore, 0.05 mole molarity, mole boleh, of acid will produce 0.1 mole or molarity of H plus. Kita assume volume dia sama, so mole dengan molarity okey lah. Volume dia 1. So put into this formula, negative log 0.1. So the answer is 1. So B is the correct answer. Ini soalan example dalam buku pun sebenarnya, kan. So lebih kepada nak membantu juga if we give you this question. Alright. Okay. Is there any question? No?
No.
Okay. KSP is the last part of chapter 7. We haven't been to this part yet. So I'm going to look at buffer first. Buffer is the one that we did last week. The last question. A simple buffer solution can be prepared by adding comparable amounts of benzoic acid and its salt, C6H5COONA. This is sodium benzoate, to water. Okay. Given Ka for benzoic acid is 6.3 times 10 to the power negative 5 molar. Usually, if we are given this, maybe we are going to use Henderson-Hasselbalch equation. If you are really clear about buffer solution, you know that buffer solution is a solution that can maintain its pH when a small amount of acid and base is introduced into the system. Larutan penampan. So the answer would be nak tulis ke buffer solution is jawapan dia ada. This one. Buffer solution is a solution in which it has the ability to maintain its pH when small amount of strong acid or strong base is added to the solution. Okay, dah. I've already repeated the definition 2 times already. And I hope you can write it down if we ask you to define buffer solution. This is a C1 level also. Define C1. List the species in this buffer system. So if we want to list the species in this buffer system, okay, we have to look at this is the acid. Okay, so the acid is C6H5COO minus, and it has also H plus. So this is 2 species from the acid, and then the same species here kita pecahkan C6H5COO minus and also Na. So this is the 2 species that is given from the salt and the acid. Don't forget, we also have H2O. So H2O would have H plus and OH minus. So what is the answer just now? And show. The answer is we have acid. Macam mana nak buka ni? We have acid. Sorry. We have acid C6H5COOH. We have salt C6H5COONA. We have the H plus and we have Na plus. So for this question, you are going to get 2 marks or no marks at all. Kalau you bagi 1 saja daripada 4, you tak akan dapat markah. Kosong. Kalau kamu bagi 2 pun kosong. Kalau bagi 3 pun kosong. Kalau bagi 4 betul semua, baru dapat 2 markah. So this is also C1. This is how we mark this kind of question because it's just C1, dia macam simple. Okay, 2 atau kosong. Okay, Alhamdulillah. So, this is the 7 marks part. When you look at the 7 marks, you would know that this will take some time lah. I have to do a few things on this. Okay, let's look at the question properly. Calculate the pH of a solution prepared by adding 2 grams of acid and 2 grams of salt, enough to make 1 liter solution. So here it says that the final volume is 1 liter. It's going to be easy if it's 1 volume. Okay, now first we have to find the number of mole of benzoic acid. The number of mole of benzoic acid, how do we get that? By finding the molar mass. 2 gram divide by molar mass. Alamak, molar mass berapa ni? 6 kali 12, 5 kali 1, and then ada lagi 1 kali 12, and then 2 kali 10, 16. Apa yang kita buat ni? Hydrogen. 1 kali 1. I am actually calculating the molar mass of benzoic acid. Okay. Barulah saya kira 6 times 12, 72 is 72 plus 5 plus 12 plus 32 kan, plus 1. So 122 gram per mol. So kita nak bilangan mol kan. Okay, darab dulu. The answer is 0.0164 mol. Potong mol naik atas. Okay. Next, we have to find the number of mole of sodium benzoate. Okay. The answer, the question is giving you 2 gram also. But then this is C6H5 C1 ni sodium. Sodium berapa? Dah lama dah tak buat chapter 1 ni, dah tak ingat dah kat mana. 23 Sir Afif?
23. Announcement it seems that I cannot access the Q&A punya part ni. Tiba-tiba jadi error, unexpected error. So if you have any question, please do ask in our Telegram group lah. Okay? Saya pun tak tahu kenapa tiba-tiba ni jadi unexpected error.
Tak apa.
Okay, you may continue, Madam Ruby.
Kalau you nak tanya soalan, terus tanya dekat Telegram. Unexpected error on the Q&A, kita tak boleh nak usik. Asalkan bengkel berjalan dengan lancar dan kita recorded. So that would be good enough kan? Okay, betul ke? Kita punya molecular mass 144 gram per mole. Okay. So the answer for that would be 2/144 is 0.0139 mole. Okay, saya memang spontan terus ni anak-anak. Okay. So now we want to find the concentration of benzoic acid C6H5COOH. The concentration is 0.0139 mole over what is the final volume? 1 liter. So the answer is 0.0. Sorry. Ini acid kan? So acid is 0.0164. 0.0164 molar. Okay. And then the concentration of the sodium benzoate would be 0.0139 mole divided by 1 liter. This is basically 0.0139 molar. So we get the concentration of acid and we get the concentration of salt. And we also have the KA. So we are going to use Henderson-Hasselbalch equation. This is basically an acidic buffer solution. Alright. So what is the formula? What is the formula for, ada tadi tak apa nama? Tak muat. Tak kat sini. Terus tengok kat sini lah. Alright. This is the Henderson-Hasselbalch equation. Henderson-Hasselbalch equation. So you want to get pH equals to negative log because we want to find pKa. So we are given Ka. The Ka is, where's the Ka? 6.3 times 10 to the power of negative 5. 6.3 times 10 to the power negative 5. Saya tak tengok lagi yang bawah tu sebab saya fokus kepada apa yang saya dah kira tadi. Plus log salt. Salt adalah this one. Okay, 0.0139 divided by this one. This is acid, 0.0164. 0.0164. So I am pressing the calculator right now. Let's do it together. 139 over 0.0164 equals to, okay, log answer, okay, negative 0.07 plus negative log 6.3 exponent negative 5 equals to 4.129. My answer is 4.1288. Ni kalau ikut kalkulator penuh lah. So pH kita biasanya letak 2 tempat perpuluhan saja, 4.13. So this is the answer for the question. We are going to get the first mark here. Kita dah bincang. Okay, 1 mark for the number of mole. Kat sini lah. 1 mark for the number of mole. 1 mark for the number of mole of salt. And then the concentration of the acid, 1 mark. Concentration of the salt, 1 mark. So 4 marks altogether by just doing these simple steps for buffer solution. So buffer solution ni memang confirm akan keluar lah kan, Ustaz Afif? Confirm akan keluar, dengar tu.
Very
So
famous question.
A famous question, and then when we do
Kata tiap-tiap tahun wajib lah.
when we do question, memang soalan ni akan dibuat lah, akan ditanya. Okay. And then 3 more marks. 3 more marks is the formula for Henderson-Hasselbalch. Okay, this formula. Jangan tertukar asid kat atas, salt kat bawah. And then Ka, don't forget to convert it into pKa. So that is common mistake lah. And then pengisian. Kadang-kadang kalau kita strict pengisian tak bagi Ustaz Afif sebab dah terror dah semua. Dah akhir semester dah. And finally, the final answer, 4.13. Put it at 2 decimal places. Okay. So, lagi satu soalan. I think we have KSP. KSP ni kita tak belajar lagi. Tapi saya boleh explain a little bit. What is KSP? KSP is kadar sesuatu larutan ionik itu larut dalam air. The definition in English, of course, you have it in the book. But what we want to understand is, if we have an ionic compound, how much can it be soluble in water? How much? Is it one ionic compound with another ionic compound which is more soluble? And then if we add same ion in the solution, can it become soluble or it become less soluble? That is common ion effect, the last part of the chapter 7. So, okay, let's read the question. At 25 degrees Celsius, room temperature, 1.31 times 10 to the power of negative 5 mole of silver chloride, argentum chloride, dissolved in 1 liter of water. What is the KSP of argentum chloride? Okay, so firstly, we need to write the expression for KSP. Before we do the expression for KSP, we need to write the equation. The equation of AgCl solid, when it dissolves in water, what will it become? It will become Ag plus in aqueous form and Cl minus in aqueous form. And the KSP would be the concentration of Ag plus, okay, this is the KSP expression, and Cl minus. This is the expression. And we are representing not X but S for the solubility. solubility. So um, this is the solubility or the amount of argentum chloride that is given to us. So we are going to insert the values 1.31 times 10 to the power of negative 5 mole, 1.31 times 10 to the power of negative 5 mole. This is the solubility value for each of the ion that is given. So all you have to do is just 1.31 exponent negative 5 square. You're going to get 1.278. Kenapa 72? Saya salah tekan calculator ke apa ni? 1.31 exponent negative 5. Okay, 1.31 exponent negative 5. 1.72, saya salah tekan. Okay. The answer is 1.72 times 10 to the power of negative 10. Okay. So this is the KSP value for AGCL. The answer would be 1.72 times this one. Okay. The KSP value will determine whether the ionic compound will become dilute or not, will be soluble in water or not. So the higher the KSP, the more soluble it is. The more soluble it is. Therefore, I take an example here for magnesium carbonate, plumbum sulfate, and barium chromate, which has 1 cation anion. Which one has the highest KSP? The highest KSP is for magnesium carbonate, which is 3.5 times 10 to the power of negative 8. Therefore, magnesium carbonate is more soluble, most soluble in water. Sometimes we will ask this in a different form of MCQ question. But this type of question also, like buffer, it is definitely going to come into your final exam. Okay, so I believe that is all for the 8 questions that we have selected. Of course, there are more questions on hydrolysis of salts, on titration, but those questions, of course, it can be tackled as you read the lesson. Okay, this is question number 1. A recap, KC, and then this is question number 2 on KC as well, and then this is question number 3 on KP, and then question number 4 on the definition and how to calculate the pH of acid and base. And then we have KSP. This is the last part of lesson 7. And also we have predicting the direction using quotient. Quotient can also be for concentration and also for pressure, both. And then number 7, this is on the Chatelier's principles. We have 4 factors, you have to know all. And finally, the buffer system, how to calculate the species for the pH for buffer, and to be able to understand that the pH will not be different much from the buffer pH at the beginning. So if we extend this question, we add some amount of sodium hydroxide. Okay, what would be the pH? So you know how to calculate the concentration of the H plus afterwards when we add the acid or the base. Okay, so I thank you very much everybody for attending the workshop. Alhamdulillah, Madam Tipah said just now ada 276 pelajar bahagi 371, ada attendance 48%. It's quite saddening lah, because previously when we do the bengkel workshop face to face secara bersemuka, semua orang hadir kecuali 1 atau 2 orang yang mungkin accident ataupun mungkin abang dia kahwin. Tu je kes khas yang kita benarkan. Yang lain semua hadir. Tengok ni, duduk dalam Dewan Kuliah Pusat 3. Ni Dewan Kuliah Pusat 3 ni kan, dia punya kapet warna kuning. Kita panggil Dewan Diraja sebab kuning. So all 500 people is actually here on a Saturday weekend, daripada pagi sampai petang. We have lunch together, we have discussion in groups, we have presentation. Ni contoh presentation pada ini workshop yang terakhir kita buat secara bersemuka. Ingat tak Sir Afif yang kita tak dapat booking Dewan Kuliah Pusat, tapi kita terpaksa guna bilik sumber. This is bilik sumber at level 4.
And also demonstration from fasting.
Yes. Kita jemput satu kumpulan penyelidikan di Fakulti Sains. Ini Dr. Zamir yang tengah ni. Dr. Zamir sekarang ni dia dah resign daripada USIM untuk membuka syarikat perfume-nya sendiri. Saya teringin nak pergi melawat. Jom Sir Afif, kita pergi dekat Kelang. Bolehlah kita bawa beberapa student terpilih yang kita boleh tengok how does he make the perfume, the what you call that, the ester that is formed, the reaction to form perfume tu kita akan belajar next semester. Tunggu. So Dr. Zamir adalah seorang usahawan yang jiwa dia tak lari daripada pendidikan. Ini masa dia masih lagi berkhidmat di FST.
Dr. Zamir ni kiranya usahawan yang berpendidikan lah, mana yang betul-betul menjual barang dengan bidang dia.
And then he created a lot of job opportunities kan. Ini kalau you ingat lagi kan, Sir Afif, this is Dr. Shazza. Dr. Shazza, dia adalah salah seorang fellow di KKNC dulu. Sekarang dia dah jadi pengetua. So bila you datang semester 2 nanti ke Kolej Kediaman Nilam Court dan berada di sana, Dr. Shazza Azhari ni adalah pengetua anda. Dia adalah pensyarah di bidang kimia juga. So all our chemistry people are very active and work hard. So you have to do this for all the subjects. Kami buat untuk kimia, walaupun subjek lain mungkin tak buat, tapi you have to focus to and prepare for your final exam. So itu sahaja untuk hari ini. Mula-mula kita ada 3 chemistry and now kita ada 4. Welcome Dr. Jana. You are very new, so nanti kita ambil gambar 4 orang. Okay, insyaAllah. Itu sahaja. All the best, everybody.
I want to share. Okay, there's attendance that you need to fill, guys. Okay, I will share. Okay, right now can you see the screen? Okay.
Sekarang ke? Kena.
Yes, I give you about 2 minutes. There's a question in the attendance form that you need to answer.
Kita nak tahulah siapa siapa yang sangat-sangat berminat untuk hadir dalam bengkel kita. Tak kisahlah berapa ramai pun. Yes, and you focus and you appreciate us. And you spend your time with us this morning. Kita memang nak tahu siapa. Dan siapa-siapa dalam ni lah mungkin kita select kan Afif nanti ikut markah exam ke next sem. Kot lah nak pergi berjalan bila dah dapat rentas-rentas ni excited je. Nah, Madam Lina ajak pergi kilang Google ke factory Google. Dia kata FST buat untuk sains komputer punya program. So kita pun berminat dengan apa-apa yang berlaku di FST, dia punya cerita akan sampai kat kita kan. So
actually TAPD ni kilang untuk FST.
Yes, definitely. We are their feeder, and then whatever information that they want us to tell you, they will give us. So macam-macam kadang-kadang bengkel kimia ni menjadi rebutan pensyarah-pensyarah FST, FKAB untuk datang memberi ceramah. Bukan ceramah, promotion. Ada satu tahun tu kita buat bengkel, Prof Abu Bakar daripada Fakulti Kejuruteraan Alam Bina datang bagi talk. Berapa lama? Sejam juga kan dia ambil waktu kita bengkel slot untuk dia 1 jam. Dia cerita macam mana apa fungsi arkitek, macam mana nak proceed career in architecture, what are you going to become. Dia tunjuk bangunan-bangunan yang dia pernah uruskan, design-design yang arkitek buat. It's so interesting that we have this opportunity to expose you for your future career. Yes. Masa you masuk Tamhidi ni, mungkin you tak sure saya nak jadi apa lepas ni.
Mungkin tak nampak lagi lah.
Tak nampak lagi. So next sem maybe you mungkin dah tahu, okay, saya perlu pilih antara 10 kursus ni apa saya nak buat. Untuk TPPS you have 10 choices. Untuk TSFT you have 8 choices. You kena tolak lah perubatan dengan pergigian tu sebab you tak ambil bio. So yang lain tu TPPS pun boleh pilih yang 8 daripada FST dengan FKAB tu. Okay. So with that we can finish the program lah. Terlebih masa juga kan. Ingat dah 2 jam je.
50 minutes only, tak apalah. Okay, so thank you very much Madam Ruby. Okay, thank you very much to our beloved Madam Ruby, Science Coordinator. Sebabkan dia pun sekarang tengah sibuk dengan audit, still ada masa untuk bagi talk untuk program ni. So hopefully guys, you guys boleh balas balik jasa Madam Ruby ni dengan skor chemistry untuk final nanti.
Yes, please. Okay. Saya sangat risau kalau you skor rendah. Saya kena defend you ni. Esok nak pergi kerja, Afif. File program tak siap lagi.
Esok ni. Itulah. Hopefully guys please score, especially untuk chemistry lah. Senang cerita.
Untuk semua.
Semua lah. Okay. So we end our workshop. Before that, Madam Tipah, are you there?
You want to say something?
Yes.
Ibu,
good luck for your final examination. Please try to do your best. And as what Sir Hafiz said just now, okay, Madam Ruby have talked a lot today to explain to you how to answer the questions, how to tackle the exam question. Okay, please use the knowledge that you have and try to get the best result for your final exam for this semester, insyaAllah.
InsyaAllah. Amin.
Okay.
For our recorded session ni, this live session, insyaAllah I will upload it next week lah, by next week. Okay, so for those who miss it, you may rewatch back lah. Okay, rewatch.
Upload dalam YouTube Afif?
Yes, I will put in YouTube.
Okay.
Okay, do not skip ad Okay, that is all for today. Okay, we end our workshop with our Tasbih Kifarah and Surah Al-As. Okay, Dr. Nurul Jannah, is she here? No tak ada Okay, tak apalah. Okay, so that is all for today. Thank you guys
Thank you.
for watching this live
Bye.
session. Okay, bye-bye. Assalamualaikum
Bye.
warahmatullahi taala wabarakatuh. N.
N. N. Siapa nak tekan N?
Saya tekan N.
Okay. Khalas. Bye.
Alhamdulillah. Dah habis dah.